There is an oceanic divergent boundary between the South American plate and the African plate. These two oceanic plates move away from each other, creating new crust. In this process, you expect to see basalt pillows and rocks near mid-ocean ridges. There's molten rock that flows up from the mantle. On the border of the Eurasian plate and the Somali plate, there are continental divergent boundaries. These continental plates move away from each other, and the plate is pulled thin to form a rift valley.
Here we have the transform boundary between the North American plate and the Pacific plate. Major transform faults on continents are relics of mid-ocean ridges. There's no volcanism, there's a low tsunami risk, but there are shallow and frequent earthquakes.
There's an oceanic continental convergent boundary between Nazca and South America. This forms trenches and stratovolcanoes over the subducted slab. This area has increased seismic activity.
Between the North American and Eurasian plate, there is an oceanic convergent boundary where the denser oceanic plate slides beneath the other. Island arcs are formed because stratovolcanoes form above the subducted slab, and seafloor trenches are also formed in this process. Here we see some horizontal lines between the African plate and the South American plate. These lines represent rifts that occur because the two tectonic plates are moving away from each other, but they are pulling on each other, creating rifts, similar to what we see in the Somali plate and the African plate.